We are given two graphs. We're given f of x, so the red graph is the original graph, and its image, the blue graph. And it tells us that a vertical and horizontal compression has happened. We want to write the equation of that image graph in terms of f of x. So normally we've been given the equation and we graph. Now we sort of have to work backwards. We've got our original graph and our blue graph, and we have to figure out what happened. In fact, they've given us 2 points. They said on your original graph, we started with 3, 9. Something happened to that point. And we end up with 1.5, 4.5. In fact, they even tell us that there have been vertical and horizontal compressions. So because that's happened, we know that y has been multiplied by something and x has been multiplied by something. Looking at the numbers, you probably can figure out that both of them are going to be multiplied by a half. Our x values have been multiplied by a half. Our y values have been multiplied by a half. So that makes sense that we've had a vertical compression and a horizontal compression. So how do we write that equation in terms of the function f? So we need to write an equation for the blue one. It's going to be y equals, because that's an equation. On the right-hand side, because it said in terms of the function f, we need to have our function f on the right-hand side. Now, looking at what's happened to f, your y values have been multiplied by a half. That's going to show up outside of the function exactly as a half, because everything that affects the y values happens exactly as you see it. The x values by 2, that's going to happen inside of our function. So inside of our function, we are going to have a 2, because a 2 inside the function means multiply by the reciprocal, multiply by a half. So this is the equation in terms of f. Now, later on, when we do all of our combinations together, basically in period 3, I'm going to introduce you to a technique for doing this, because it's not always going to work out so nicely that you can just go from 3/9 to 1/2, 4.5. If they tell you it's only vertical and horizontal stretches and compressions, for sure, you'll be able to just look at one point and figure it out. But sometimes what's going to happen is that after doing this, we're going to find out after doing that, that blue graph might get shifted. So if I just trace over my blue graph here, my blue graph might be shifted over here or something. And then you will not be able to just look at this point and say, I can see what happened, because too many things are going to happen at once. So I'm going to show you a technique that we're also going to use later to show you how it works at this point, and that way when we see it later again, it'll be a second time that you see it. Okay? It's more complicated. Obviously, the first way that we did things was really nice and simple. But one of the things that we're going to notice is that if we take 2 points, so I've got 3, 9, I'm going to take this point as well, 2, -8. I'm going to call this point A and this point B. The corresponding points on my blue graph are this one at 1, -4, and this one at 1.5, 4.5. I'm going to call this corresponding point on the image, and this is often notation you'll see on an image graph, A prime with a little dash. That means that that point was connected to this point A. And this point here I'll call B prime, B with a little dash, telling me that it was connected to the original point B. And what we're going to do to figure out what we already figured out in the easier way, okay? I'm not saying this is an easier way at this point, but this will be a way that's going to help us later, is we're going to analyze what happens to the x values from A to B on both the blue and the red graph. what happens to horizontal distances and what happens to vertical distances. So if we start with horizontal distances, and we look at our original, if you go from A to B, how much do you have to travel horizontally? You go from 2 to 3. Can you see that you've moved over? The distance between them is just 1. But if I look at the horizontal distance from A prime to B prime on the blue one, I go from 1 to 1.5. It's only 0.5. How do I move? Wow, that is a bad squiggle bracket. There we go. Yes, nice. What would you have to do to change a 1 to a 0.5? You would have to multiply, because it's horizontal, your x values by a half. Looking at our vertical distances, again, looking at going from A to B, you go from -8 all the way up to 9. That would be going up 17. But if we look at going from A prime to B prime vertically, we're going from -4 up to 4.5. That's up 8.5. Again, this is vertical, so how do I change a 17 to an 8.5? I multiply y by a half. We got the same values. Obviously, this is more work because you have to find another point. And it's more, I would say, more confusing right now because the other one, it was really easy to see how it happened. But what the reasoning for this is if my image graph got shifted like I did over here, we would still have an A prime point and a B prime point. And this horizontal distance would still be 0.5 here even after it's been moved. And it still would go up 8.5 even though it's been moved. And so later on, when this does happen, that's going to still allow us to figure out that our x values have been multiplied by half and our y values have been multiplied by half. Because translating it's not going to change how that horizontal distance has been changed or that vertical distance has been changed. But for right now, I would go with this. You can just take a point, easily see that only one thing has happened, and find the new point. Later on, when more than one thing has happened, we're going to have to go to a little bit more complicated strategy. Okay, questions to do are 5, 12, 13, and 14.